When looking at what quadrant theta lies in, it's helpful if you have some relationship to 0 in regards to the trig functions. Let's take a look at the first example in purple. Sine of theta is greater than 0. Any number that is greater than 0 is positive, so therefore we're looking for a positive y value. Well, those happen to be in quadrants 1 and 2. If we're looking at cosine of theta being less than 0, we're looking at negative x values. Negative x values happen in quadrants 2 and 3. Therefore, the overlap happens to be in quadrant 2. Let's move down now into the yellow example. Cosecant of theta is greater than 0. Cosecant of theta, remember, cosecant has a relationship to sine, so we're looking for, again, a positive y value. And cotangent of theta, remember that we're looking for x and y, both of them being positive or both of them being negative. So we're looking at positive x and y values, or both of them being negative in this case. Positive y values, going back to the previous examples, in quadrants 1 and 2. But cotangent being positive happens to be in quadrants 1 and 3. Therefore, the overlap is in quadrant 1. Moving to the top right with the green example. Secant of theta is less than 0. Secant has a relationship to cosine, the reciprocal function, so that means, again, we're looking for a negative x value. Negative x values happen to be in quadrants 2 and 3. And then we're looking at tangent of theta being greater than 0. So this is, again, similar to our cotangent, where we're wanting to find a positive x and y values, or both of our x and y values being negative. So that way when we look at the fraction, the negatives would cancel out, resulting in tangent being a positive value. So therefore this happens to be in quadrants 1 and 3. The overlap in this example is in quadrant 3. Our last example, taking a look at the tangent of theta is less than 0 and the sine of theta is greater than 0. Tangent of theta is less than 0. We're looking for at least one of the coordinates to be negative. So we're looking for a negative x or a negative y. Now these happen to be in quadrants 2 and 4. And sine of theta being greater than 0, sine being the y value, so we're looking for a positive y value. So this happens to be in quadrants 1 and 2. So therefore the overlap happens to be in quadrant 2. Now taking a look at these examples, we're looking at both positive and negative degrees and radians and figuring out what quadrants they would be in. 400 degrees is simply just one extra rotation around the unit circle. So there I've already gone 360 degrees. I just need to go an additional 40, and so therefore I would be in quadrant 1. If you look at your unit circle, if you were to go a positive 225 degrees, that would put you in quadrant 3. If you were to go positive. But what I'm going to do is use that same distance that I went around, but I'm going to go in the negative direction. So therefore, it's going to put me into quadrant 2. Negative 2 pi over 3. If you were to go positive 2 pi over 3, that is going to bring you into quadrant 2. But if I'm going to go negative 2 pi over 3, I'm going to go that same exact distance, but I'm going to go in the negative direction, and so therefore it's going to bring me into quadrant 3. 9 pi over 4 is again an additional revolution around the coordinate plane because it is greater than 2 pi. So 2 pi in this case would be the same as 8 pi over 4. So therefore I know that I'm going more than one revolution around the coordinate plane or around the origin, and therefore I would just go an additional little bit more and my answer would put me into quadrant 1.